Guys, it's Miss CL here. I'm going to do lesson 6.1 with you. Let's go ahead and get started with your think about it. It says it wants you to complete the table below. So you have 3 columns in your table. Okay, we have multiplication expression. Okay, that's a number sentence with a multiplication sign, you'll notice. Then you have your product. Basically, what is your answer for your multiplication expression? Finally, you have your exponential expression, and I'm going to see if you guys can figure that one out on your own without my help. It does want you to explain how you came up with each exponential expression, so it wants you to tell me how you came up with the answers in your third column. All right, go ahead and pause the video. Okay, so let's see. Our multiplication expression is just 3, so the product of just 3 is 3. If I look at all the other exponential expressions that I have in this table, I can see, let's look at this one, the 3 to the power of 2. If I come over here, how many times did I use the number 3? 1, 2 times. Notice we have 3 to the power of 2. In that case, if I only have 1 3 over here, our exponential expression would be 3 to the power of 1 because there's only 1 3. Now let's move to the next row. We have 3 times 3. What's the product of 3 times 3? Product of 3 times 3 is 9. And it already gives us the exponential expression. All right, next row. Let's see, this time we have to come up with our multiplication expression. We're given a product of 27. And we're also given our exponential expression of 3 to the power of 3. So if we're following the rules like the last one, 3 should be the number that I should be multiplying over and over. The little 3 up here should be the number of times that I multiply that bigger 3 by itself. So if I'm making that multiplication expression, that would be 3 3's multiplied by themselves.
3 times 3 is 9, and then 9 times 3 is 27.
All right, last row. This time we have 3 times 3 times 3 times 3. That one's going to be a little bit tough here. We got to figure out the product first. So we got to start just from the left. Just like we would read, we treat them in order from left to right. So what's 3 times 3? Well, that's 9. I'm going to bring down the rest of the problem with me because I only want to make one change at a time. Okay, 9 times 3. 9 times 3 is 27. Made my one change, and then I'm going to copy the rest of the problem that I didn't use. Finally, we're left with 27 times 3. And 27 times 3 comes out to 81. So the product is 81. Now to build our exponential expression, we just have to use our big number, which is 3, because that's the number that's being multiplied by itself. Again, we call that the base. And then the little number is the number of times we use the 3.
1, 2, 3, 4 times in this case.
So the exponent, or the little number, is the number of times we multiply the base by itself. Let's move on. Key point. A blank represents the number of times the blank is blank by itself.
Can you figure it out?
An exponent represents the number of times the base is multiplied by itself. So if you looked back at our learning target, we are going to be using the order of operations, but also we're going to be learning about exponents at the same time. So let's go ahead and get started with example number 1. Expressions A, B, and C are below. Which expression or expressions have the same value as 5 to the power of 3?
And that's the way that we say exponents. We say blank to the power of blank.
That's the way I say it. There's other ways you can say it too. You can
Also say blank to the blank power. So in this case, we would say 5 to the third power, or 5 to the power of 3.
5 to the power of 3 means I'm going to take that base 5 and multiply it by itself the number of times the exponent tells me.
I wrote a 3 because our exponent was 3.
Okay, let's multiply that out so that way we know how much 5 to the power of 3 is equal to. So we always want to start again from left to right. 5 times 5 is 25. I make my one change and then I rewrite the expression. Now we're left with 25 times 5. 25 times 5 is 125. So 5 to the power of 3 is equal to 125. So now let's check and see which of these expressions are equal or have the same value of 5 to the power of 3 or 125. So I'm going to break down this empty space here to show our work. So we have 3 to the power of 5. So our base is 3, so that's the number we're going to multiply by itself. And the exponent is the number of times we're multiplying it. So 3 to the power of 5 is the same thing as
3 times 3 times 3 times 3 times 3. So there's 5 threes. 1, 2, 3, 4, and 5.
Okay, so let's go ahead and start multiplying that out and see what that product is. We always start from left to right. So 3 times 3 is 9. We make our one change and then we bring everything else down that we didn't use. In other words, the things that are not underlined, we bring those down again. Now we're going to do 9 times 3. 9 times 3 is 27.
And again, we bring down everything that was not underlined.
27 times 3 is 81.
And again, bring down everything that wasn't underlined.
Finally, 81 times 3 is 243. So is 243 equal to 125? No. So that means 3 to the power of 5 is not equal to 5 to the power of 3. We can't just switch those numbers around. So let's try B. This one is where it's getting a little harder because if you notice, our number sentence or our expression has several operations.
We've got division, we've got addition, and we have exponents.
So this is where the order of operations comes in. Please excuse my dear Aunt Sally. And the reason I like to write it like this is because you have to remember that multiplication and division have to be done from left to right. Same with addition and subtraction. We do them in order from left to right. We treat M and D as equals, and then we treat A and S as equals. So again, you do them in order from left to right.
Left to right.
All right, so let's go ahead and see if we can solve the expression we have for B. We have 6 to the power of 2 divided by 3 to the power of 2 plus 11 to the power of 2. And I forgot to mention this up above, but when you have the power of 2, we use a fancy word for that one, and we say squared. And then when we have an exponent of 3, we also use a special word and we say cubed. So we have to start using PEMDAS. So P, do we have any parentheses in this expression for B? There are not any parentheses. So let's move on to the next step. We have exponents. Yes, we have 3 sets of exponents here. So we got to solve those in order from left to right. Okay, so we start with 6 to the power of 2. 6 to the power of 2, or 6 squared, is 6 times 6. And 6 times 6 equals 36. So I made my one change, and I need to bring down everything else that was not underlined. Now, I still have exponents, so I'm going to hop over that division problem and go ahead and solve the next exponent. 3 to the power of 2, or 3 squared, is the same thing as 3 times 3, and 3 times 3 equals 9. So I bring down everything else that was not underlined. I'm rewriting my expression after each step. We have one last exponent to do, so let's go ahead and solve that. 11 squared is the same thing as 11 times 11, which equals 121.
Always rewrite after every step.
All right, so now we've done all of the exponents. All that's left is multiplication and division, then addition and subtraction. Since multiplication and division come first, we got to do those ones first. Do we have any multiplication or division problems in this expression? Yes, we do. We have 36 divided by 9. So 36 divided by 9 equals 4.
And again, I rewrite my expression after each step.
There are no more multiplication or division problems, so we're done there. And now we move down to addition and subtraction. We do have an addition problem, so let's go ahead and solve that. 4 plus 121 is equal to 125. So this one does match. It does have the same value as 5 cubed, or 5 to the power of 3, so we need to circle that one. And then last but not least, let's check out C. We have 66 minus 5 plus 4 cubed. All right, so the process with PEMDAS starts all over again. We have to start with P. Do we have any parentheses? No. So we move on to E, exponents. Do we have exponents in this round? Yes. 4 to the power of 3.
Now 4 to the power of 3 is the same thing as 4 times 4 times 4. 4 times 4 times 4 is 64. Because 4 times 4 is 16, and then 16 times 4 is 64.
So I evaluated my exponent, and now I need to bring down the rest of my problem. Okay, any more exponents? Nope, we're done with that. Now we move to multiplication and division. Do we have either of those in this problem? Nope. So now it's addition and subtraction. And this is where it's going to be really important that it goes left to right. Because if you notice, we have a subtraction problem first, and subtraction technically comes after the A in PEMDAS. But that doesn't matter. Remember I said that addition and subtraction should be treated as equals, and you do them in the order that you read from left to right. So that means we have to solve 66 minus 5 first. 66 minus 5 is 61.
Then we bring down the rest of our problem.
We're left with one last operation, 61 plus 64, and when I add those together, I get 125. So C is also equivalent. So that was a lot. If you need to go back and rewind it, you can pause it as you need to. But let's go ahead and move on to example number 2. 2 more problems we're going to work out together. It says evaluate each expression. And what the word evaluate means is to solve.
Solve each expression, okay?
So we always start with PEMDAS, and it's a good idea when you have a number sentence that has multiple operations to always write PEMDAS on the side. Then you kind of can use it as a checklist. All right, so let's get started. Do we have any parentheses?
Nope.
So let's go ahead and move on to E. E stands for exponents. Do we have exponents? We sure do. We have 6 to the power of 3.
Remember, 6 to the power of 3 is the same thing as 6 times 6 times 6. 6 times 6 is 36. Bring down the rest of our problem. And then 36 times 6 is 216. So 6 to the power of 3 is 216. I made my one change, and then I rewrite my expression.
Any more exponents?
Nope, let's check it off our list.
Do we have multiplication or division? We do have a multiplication problem in there, so let's go ahead and solve that. We have 7 times 4. 7 times 4 is 28.
We made our one change, and we rewrite everything that wasn't underlined.
Are there any more multiplication or division problems?
Nope.
So we move on to the last step, which is addition and subtraction. We only have one operation left. It's an addition problem, and it's 216 plus 28.
Okay, when I add that up, we get 244.
244 is our final answer. Finally, number 2. This one has a lot of different operations in here, so we better get our PEMDAS written on the side. And let's get started. Do we have any parentheses?
No.
Exponents.
Yes.
We have 9 to the power of 2.
9 to the power of 2 is the same thing as 9 times 9.
Which we know is 81.
Now I rewrite my expression. Okay?
Any more exponents?
Nope.
So let's move on to multiplication and division. We do have both. We have a division problem and a multiplication. So we need to do them in the order that they come. So the first one we got to work with is 81 divided by 3. 81 divided by 3 is 27.
I made my one change, and then I rewrite my expression.
We still have that multiplication problem there, so we got to solve that first before moving on to the next step. We have 27 times 2.
27 times 2 is 54. Make my one change, and then I copy down the rest.
All right, no more multiplication or division. So now we're on to addition and subtraction. We got to treat those in order from left to right. So we start with 4 plus 54.
4 plus 54 is 58. And I bring down the rest of my expression.
One more step to go. We have to subtract 58 minus 2.
58 minus 2 is 56.
All right, guys, I do want to make a note about one of the problems for the 2-star level. So you know we've learned about prime and composite numbers. A prime factorization is basically the number sentence of prime numbers that when I multiply them together would multiply to equal 72. So what I want you to do is I've posted a link in the description of this video. I want you to go and watch it. It's on a website called Virtual Nerd, and they're going to explain what prime factorization is. Okay, I want you to watch that problem before you solve number 4 on the 2-star level problems, okay? If you have any questions, you know my office hours are Monday through Friday from 12 to 3. Hope you guys are doing good.